Hello, viewers, and welcome. I am your host, Horizon, and today I am playing Human Resource Machine. It's a very fun game, although, admittedly, this is my first time playing it. But what I've heard of it is that it's a game that sort of teaches you basic programming. Considering that I'm going to college for computer science, I already know some programming, so this should be a breeze for me. Here we're just chaining inbox, outbox commands. Inbox means you take whatever's in this queue or stack here, load it into your loaded into your your worker here. Outbox means takes whatever's in your worker's hands and puts it in the output queue. And if you do that 3 times, you complete the level. Very simple. But don't worry, it gets harder. So, this introduces the jump command, which is where things start getting interesting. Jump means, alright, go to a different part in the program. So, here, we're using jump to jump after the inbox-outbox sequence to bring the operator back to before the inbox-outbox sequence and just repeat it until it's out of things to inbox and it just halts. And there's a slider down here to speed things up. The letters here spell out boot sequence. Incidentally, the phrase, the booting up a computer comes from way back when punch cards were still a thing, and if you don't know what a punch card is, go look it up. I'm not going to explain it. But you had to put in a stack of cards when you started up the computer for the first time, or any time, you had to put in a stack of cards in a certain sequence. Now that stack of cards was the boot sequence, or in full, the bootstrap sequence, because you had to lift the computer up by its bootstraps. And yeah, there wasn't an operating system built into the computers at that time, so you had to load the operating system in via cards every time you started it up. And this was a process apparently equated with pulling yourself up by your bootstraps, i.e. physically impossible. Not really sure how that's related, but it is true. Look it up on Wikipedia. I will admit, I am not the best teacher ever. But yeah, I completely failed to explain what the hell I did there. I'll explain here. Alright, so, inbox, pick up the first thing in the queue, then copy to register 0. These 3 squares here I'm going to call registers. Register 0, register 1, register 2. Remember, with computers, you always count starting with 0. So, when you inbox, you put something in your hands. If you inbox again, you discard what's in your hands, it disappears, and now you have a new thing in your hands. That's the same way for your operator here, and for the registers. If you copy to a register while there's already something there, what's already there disappears, and what wasn't, and it's replaced by what you were putting into it. Anyway, what he wants us to do is take two things in and put them out in reverse order. So input 1 right here, remember we count from 0, becomes output 0, and input 0 becomes output 1, and so on and so forth. So inbox, copy to there, inbox, outbox, then copy from register 0, and outbox that. And then jump back to start and repeat the process. See? Piece of cake. And here's a cutscene, which I'm pretty sure means absolutely nothing, because this is made by the people who made World of Goo, who are famous for making meaningless plots. Or maybe I just didn't like the plot of World of Goo, or I just can't remember it. I don't remember the plot of World of Goo, only that it was kind of dumb. Alright, now we bring math into the equation. No pun intended. Alright, inbox, copy to register 0, inbox again, add with register 0, then outbox. So what this does is you take input 0, copy it to register 0, take inbox 1, add, copy register, whatever's in register 0, and add that with what's in the operator to create, in this case, 8, and then you outbox that. And then we repeat the process. So, inbox, add, and outbox. Piece of cake. We're gonna go down this little branch here. So, for everything in the inbox, triple it and outbox the result. Inbox, copy to register 0, add register 0, add from register 0, and outbox. Jump, and let's see how this works. Hooray. So here we introduce the concept of challenges, and optimization, and all that. Basically, it's not enough that your code get the job done, it also has to do it neatly and elegantly. So, here we have to multiply the input by 8 and output it. The challenge here is to do it with only 3 add commands. How do we do that? Simple. First, you have to inbox it, copy to register 0, add from register 0. Now, here's where it gets interesting. Copy to registers 0. So, the 1 here, we inbox that, copy it to register 0, add with register 0, we get a 2 in the operator's hands, then we copy that to register 0. Now we add 2 to 2, copy that one more time, add 4 to 4, then outbox that. And repeat as necessary. And now, here it gets tricky. We have to multiply the input by 40, which is not a neat power of 2 number. Step 1, inbox it. So step 2, let's copy it to there. I'm not entirely certain what I'm doing here, honestly. I'm just sort of playing it by ear now. But my line of thinking is 40 is divisible by 5, and there's 5 registers, so if we make use of all the registers, so let's test this. This button right here progresses 1 step. Times equals that, times 2, times 3, times 4, times 5. So that multiplies it by 4 times 5 is 20, so multiply it, so double it 1 more time. Wait, no. There we are. This should, in theory, work. I'm not sure. It looks like it's working. Yep. Looks like it's working. Hooray. So I didn't optimize it. But, oh well. Zero exterminator. So now we get conditional statements, or commands. Jump if 0. So this is pretty simple. Inbox. If it's 0, jump up, and inbox again, clearing 0 from the cache. Otherwise, continue on to outbox. Ah, crap. Don't forget to put the jump at the end, children. Hey, I optimized it. Yay. Alright, so now we have to reverse that. Inbox. Jump. So, let's start with an outbox command. Then inbox, if 0, jump to outbox. And if not 0, jump to inbox again. God damn it. Okay. It's a tangled spaghetti mess, but oh well. I hate everything right now. I just want you to know that. Alright, so we got that working. Incidentally, if you're wondering what programmers are like, this is a good... I'm a decent example. Getting mad because I can't figure out simple problems immediately. Alright, now we can subtract things. Another vital element in math. Right. I should probably check and see how long this has been going. Oh. Yeah, I'm just gonna call things here. Night, everyone.